All right, number 30, solve the system. If the system has indefinitely many solutions, write the solution set with x arbitrary. And again, just like number 29, we have three equations, three unknowns, x, y, z. Equation 1, 5x plus y plus z equals -4. Equation 2, x minus y plus 5z equals 6. And equation 3, 5x plus y plus z equals -12. And I'm going to go ahead and label each of our equations just as 1, 2, and 3. And this will kind of help us to stay a little organized. And notice that with equation 1 and equation 2, notice that the y variables cancel right off the bat. We don't even have to do anything to these equations to get the y's to cancel. So let's start with equations 1 and 2. So let's rewrite 1 off to the side here. And let's rewrite 2 off to the side here as well. All right. And again, what's nice about this system is with equations 1 and 2, the y's cancel right off the bat. So 5x plus x gives us 6x. The y's cancel. Z plus 5z gives us 6z. And -4 plus 6 is +2. And now that we've eliminated the y variable from equations 1 and 2, let's go ahead and rename, or rather name, this new equation that we came up with as equation 4. And we'll come back to this equation in just a moment. But now let's look at equations 2 and 3. Remember, we haven't used equation 3 yet, so now we have to introduce it into the process of solving this system. And we want to also eliminate y from this third equation here. And because equation 2 and equation 3, if we pair these two equations up, the y also disappears. It eliminates without having to do anything. Let's pair up equations 2 and 3. So we have x minus y plus 5z equals 6. And equation 3, which we've not used up until this point, 5x plus y plus z equals -12. All right, and again, just like up here, we're going to eliminate the y. So we have x plus 5x gives us 6x, -y plus y goes away, and 5z plus z gives us 6z, and 6 minus 12 is -6. And now that we've eliminated the y from equations 3 and 2, let's rename, or rather name, this new equation that we came up with as equation 5. And now using equations 4 and 5, these are the two new equations that we came up with, let's try to get rid of either x or y. But first, let's go ahead and write them one on top of the other. So there's equation 4 and then equation 5. We'll stack underneath. And let's go ahead and how about we try to get rid of, well, let's try to get rid of the x, all right? And we can see we have a positive x and a positive x. So if we were to multiply this top equation by -1, we will end up with -1 times +6x is -6x. +1 times +6z is -6z. +1 times -1 times +2 equals -2. And now we can go ahead and add 6x minus 6x goes away. 6z minus 6z goes away. So on the left-hand side of our equal sign here, everything canceled, so we're left with 0. And then on the right, we have -6 minus 2 is -8. And so what do we have here? Well, we have the statement 0 equals -8. Is this true? Does the number 0 equal the number -8? No, of course not. That's a false statement. And we know when solving by substitution or elimination, when you're solving a system, if you get a false statement, you know that your system has no solution. And so again, in this case, just like number 29, as we were going through the process of solving, we ended up in one of our steps with a false statement, so we can stop here. We can't go any further. There's nothing else we can do. We know that this system has no solution. There is no ordered triple, no x, y, z, no combination that we could plug into each of these equations to make all three of these equations true. And so since there is no ordered triple, that means there is no solution, and we will simply go ahead and indicate that with number 30, and we can take a look at number 31.